Okay, good afternoon, everyone. I am Minna Haikonen from Helsinki, Finland, from Finnish Meteorological Institute. And I warmly welcome you all to listen to February's weather briefing. At first, I think it would be nice to introduce ourselves to each other. So I will give you now rights to use the annotation tools so you can put your names on one of the boxes, whether you are forecaster, and place a mark somewhere on the map where you are at the moment sitting at. Okay, someone made a huge trip from all around the eastern part of Europe. Okay, I see that most of us are forecasters or researchers, and then we have a couple of trainers also, and one other. And I see that most of the participants are located somewhere in the middle or eastern parts of Europe. So I think I am sitting in the most northern part of the Europe at the moment. Okay, let's start with the actual presentation now. First, I would like you to see the water vapor image from 300 hectopascal. And I have also the 300 hectopascal pressure field here, and I think it's really quite uniform, at least in my opinion. Usually the upper field doesn't behave so uniformly, or it's not so homogeneous as at the moment, because we have the large low pressure area located in the northern parts or almost at the Arctic regions, and then we have the small area of high ridge here, and then some higher pressure area here in the south. So we can see that the pressure gradient is really strong here, all the way from northern Atlantic through the central parts of Europe, all the way down to the Mediterranean area and the eastern parts of Europe. So basically only the Scandinavian area or the northern parts of Europe is at the moment in the state where the gradient isn't that strong. Then second image, I have the EUMeTrain RGB. So now I would like you to draw a line where you can track the warm air and cold air kind of dividing into the whole Europe. So now I will give you the rights to use your annotation tools again to draw a line where you assume that the cold air and warm air are dividing into. And of course you can also write, can be as creative as you wish by stating out where the cold and warm air is located at. And of course, when I'm sitting up here north, it's also always nice to remind that we have a problem with the limb cooling effect when the viewing angle is so narrow here up north. So, of course, usually at this time of the year, we have the cold bluish air mass anyways, so it's more of a problem during the summertime. Good, we have really good answers. So now I will stop the writes for you to use the annotation tools. And actually, in the next slide, I have the ECMWF 850 hectopascal temperature field. And as we can see, the really cold Arctic air mass is located really north. We have fairly cold winterly temperatures at the moment in Scandinavia, and then the cold air has fallen down more deep into the south, almost to the Mediterranean area. We have the 0-degree line here. So it was really good answers that you gave. And you found from the air mass image. Good. Now the next question is, can you define jet streams? Because sometimes it's really easy and the descending stratospheric air is really easy to define from the air mass image. But sometimes it can be a little bit more difficult. And again, I will give you the rights to just a moment. Now I did something wrong. Are you able to use the? Okay, I think you are able to use the tools now. Yeah, I can see really good lines. I think you have been on track with the weather situation at the moment. And the first slide was really good hints because we already know that we have really strong pressure gradients throughout the whole Europe. Good, thank you. So in this slide I have also the ECMWF 300 hectopascal wind speeds, and you really nailed the question. We have this really strong jet stream that has been divided into different stronger jets coming from the northern Atlantic, and it's really hitting hard the western parts of Europe, and then it's going up again here in the eastern parts where it's a little bit, or not little bit, it's quite a lot weaker here in the Eastern Europe. Good. So then I have a weather analysis from yesterday where we can see really quickly the analyzed fronts we have, and it's quite an interesting situation for us here in Scandinavia and in Finland, because it's been really gray and windy, and at the moment we have already we have also the really large low pressure area here in the northern Europe, and basically in the parts of Middle Europe also, but here in Scandinavia we have this really weak and small high pressure area in the middle of this all surrounding low pressures. So as you can see, and you very well know that there are really several really fast moving and developing, deepening low pressures moving from North Atlantic to southeast, and there are and have been cases for heavy rain, and especially the wind has been really strong throughout the Western and Southern Europe. And at the moment, it's not so windy here in the northern parts, but it really has been really windy and funny winter anyway, so I will talk about that later on. And here I have a forecast for the moment. I did this in the morning, so at the moment it was forecast, but as you could see that, as I mentioned, that at the moment we have these really fast-moving low pressure areas here that are causing some heavy rain and strong winds. And then we can look at the meteor alarm system, where we can see the warnings throughout the whole Europe. And as you can see, there are several warnings in many countries, especially about the winds, really strong westerly winds, and alongside, because we have the colder air now, finally moving from north to south, there are also warnings about bad driving conditions, and also in some countries also warnings about low temperatures at the moment. And flooding has been a problem here in Finland, which is quite exceptional considering the winter time. It's usually a problem only springtime, but at the moment there are also flooding warnings in the middle parts of European countries. Okay, so as I already mentioned, it's been really windy, and low pressures have been dominating the weather, especially here in the western and northern parts of Europe. And here I have a mean sea level pressure anomaly from the beginning of the year. And I got it from the reanalysis system from NASA. And as you can see that the pressure anomaly has been really lower than average here in the northern Europe, and somewhat higher in the central and southern parts of Europe. So this has been the problem here in Scandinavia, parts of Scandinavia, and here in Finland, that we really don't have a proper winter at all here in southern and western parts of the country. And on the other hand, on the northern parts of Finland, we have really much more snow than average, and I will show you some statistics about that in a moment. But in all, this has been the situation throughout the winter all around the Europe, that we have had really strong westerly airflows, and it's been a dominant throughout the beginning of the year. And here in Finland, we have had only 2 short cold air outbreaks. So, as I mentioned, it has led to a situation that we are lacking snow in southern and western parts of the country, where we usually every year have snow cover at the moment. And yeah, so I guess everyone knows from this that the positive North Atlantic oscillation has been dominant. So I already or I also found this product. I don't know if you are familiar with this product, but Just very briefly, we don't use much time with this, but we have used it especially this winter quite a lot, and it's been quite good tool for us to predicting how the bigger picture of the weather situation is going to develop throughout the winter time. And this is ECMWF's daily probabilities for the occurrence of Euro-Atlantic weather regimes. So we have all the ensemble members here that are located in different regimes. We have the North Atlantic oscillation positive with blue color, and then we have blocking with red color, and the North Atlantic oscillation negative with green colors, and then Atlantic ridge with violet colors. And the grayish colors state that the members can't be defined in any of the regimes. So as you can see that the Neo Plus is going to dominate the weather, at least in the beginning of the March also, as it has been dominating the weather already in December and January. But if we look at more on the second week, then we can see that we have some probabilities that we might have the blocking situation developing. And finally, we could get some kind of change for the Neo Plus domination here, but it seems that it's still fairly unsure. We still have here some probabilities for the Neo Plus situation going on. Anyways, but this product can be found from the ECMWF site, and it's been really nice product, and you can find some more information about the product, how it's being calculated, and but also I decided to add this one to explain more about the regimes. We have the 4 regimes here that are also in the previous graph that I showed you. The first one on the left upper corner is the Neo positive regime, and the Neo negative regime is on the right upper corner, and then we have the blocking on the left side down, and then the Atlantic ridge on the right down corner. And this is really nice image that I just found out. I haven't never actually been looking at this graph, because here they have been calculating over the era interim period from 1980 to 2008 that how often do we have these different regimes. So the Neo positive is actually 32.3% of all the regimes that we have had throughout the years, and then the negative Neo we have had 21%, and then we have had blocking 26%, and 20% we have for the Atlantic ridge. So considering these numbers, it's been, because for this winter time we have had, I think, maybe 80 to 90% the Neo positive regime for the bigger weather picture. So it has been really unusual winter time in many senses. So let's move on to the smaller picture from Finland, because as I already mentioned a couple of times, it's been really quite exceptional. many ways. So first I have here the current snow cover situation, and as you can see, in northern parts of Finland, the snow depth exceeds 100 centimeters in several measurement points, but in southern and western parts especially, we are lacking snow, and it's really exceptional because usually the snow depth is at least a couple of centimeters to 20 centimeters all around here in southern parts of the country. Here I have the snow depth anomaly chart. So in northern parts we have 20 to 50 centimeter more snow than average, and as you can see, especially in the eastern parts, we are lacking the 50 centimeters of snow that we usually have. And in meteorological sense, the winter hasn't even started because the mean daily temperature has never went under the 0 degrees that it would be if we could define that the winter has started. At least it has to be 5 days or so under the 0 degrees that we could define it meteorologically to start. But at the moment, we are living really exciting moments because now we are having at least 5-day period that we might have daily mean temperatures under 0 degrees here in southern parts. So it might happen that we actually have winter starting, but then again, the springtime is approaching and March is beginning. So it's really the final moments to have winter starting. So all in all, the day mean temperature anomaly has been 3 to 7 degrees greater than average in the whole country. So it's been really warm throughout the winter time from the beginning of December. And due to the low pressure activity, I already mentioned that it's been really windy and moist. It has been all around Europe, especially in the western and northern parts, but here in Finland, the rain amount anomaly has been up to 2 to 3 times greater than average in several regions. And it's not a big surprise when we look at the chart from the northern parts of Finland, because you already saw the snow depth anomaly. So it has been really rainy there, but then again we have had also really rainy in the western and southern parts of Finland. And it's been really exceptional with the flooding problems, because we usually don't have flooding problems until springtime, but now we have had several warnings throughout the winter time in the southwestern parts, where you can see that we have had also almost 200% more rain than averagely. Then I have also the ice chart from the Baltic Sea, and again, it's not a surprise that the ice cover in the region has been almost non-existent. It's much less than average. On the right side image, you can see the ice cover averagely at this time of the year, and on the left side we have the ice chart at the moment, and as you can see, we have fast ice with the grayish colors here, only in the very northern parts of the Bay of Bothnia here. So if we look at the average chart, we should have proper ice cover also, at least here in the southern parts, but also here throughout the whole western parts of the Baltic Sea area here. But then again, icebreakers have not been needed as much as usually. We have had only 3 icebreakers working here in the northern parts of the Bay of Bothnia. So then I decided, because we have this really nice opportunity now, because we have the weak high pressure area here and clear skies, and when we talk about snow and ice cover, I decided to present you some of the problems we have with tracking the snow and ice cover with MSG products, and then I would like to present you some of the VIIRS products that we have from the polar satellites that are really helpful for us in many ways, and especially now that we have clear skies, it's a nice way to look at the snow and ice cover here, because we don't have clouds. But first, I'll show you the couple of MSG products that we usually use. We have the day natural color. This we have 3 kilometer resolution, and as you can see, because we have the really bad viewing angle, so these images are really quite not usable, especially in the northern parts of the country. So the resolution is not really good. We can barely see that we have some ice here, as you could see from the ice chart in the previous slides. But then again, also we can define that somewhere here we have the snow limit, and in the southern and western parts we don't have snow at all. The resolution is quite poor. And then we have, of course, high resolution visible clouds products. This we have with 2 kilometer spatial resolution, so the resolution is a little bit better. But then again, we have the same problems in the northern parts and always with the bad viewing angle. So the help from the polar products is really needed. And of course, the lack of daylight is an issue throughout the whole winter season. We usually use the 24-hour products for tracking the weather, but it's not really helpful with the ice and snow cover, the 24-hour microphysical products. So let's move on to see what kind of polar products we have in use. And these aren't even operationally in use at the moment. These have been produced previously in the beginning of this week. So I am almost the first person here in our office that is using the products at the moment, because we are renewing our workstations and our production here. So we are really looking forward to getting these 2 actual forecasting tools. So the first one we have here is the True Color RGB, which is really nice. It's really nice for your eyes because it's quite naturally looking. And in comparison, I have here the MSG high resolution visible clouds RGB. And obviously the resolution with the 1 kilometer here in the True Color VIIRS image is really nice. But of course the issue here is that how to distinguish snow and ice from clouds, because they are both white. I also included here the channels that are used in these products that I'm going to show you. So in the True Color we have only the visible channels, so it might be a little bit difficult to define where the clouds are when we have also snow and ice. And I think we could look at the area here in the center. We have the ice here, but we can't be really sure if the area here, whether it's ice or clouds, and also here. And also the cloud area here is mixed with the ice here. But all in all, it's really nice products, and especially if we also have some green in the springtime, we would see that, of course, also here really nicely when the nature is going to get alive in the springtime. Of course, we can also see the algae from the sea areas also with greenish colors. Then the second product, it's quite familiar for everyone, I think, because it's the same that we use from MSG, the day natural colors RGB. But then again, the resolution is really nice, and it's a little bit maybe easier to distinguish ice from clouds, at least here. And already we can see that this area that was maybe a little bit difficult to define from the true color image, we can see that this is definitely ice, and this area here is clouds. And again, we can see really nicely the snow line here crossing the central parts of Finland. But then again, well, the high cold clouds are quite similar with the snow and ice covered areas, so it's not that, or maybe the best product for the ice and snow coverage detection. And here, for comparison, I have the MSG image also, the true color. So it's really big difference with the resolution. Then finally, I have a couple of more products that we use sometimes, and hopefully are going to use a lot more often when we get this in use in our operational room. We have the snow and ice cover. Sorry, the red snow RGB here, and it's really nice way of detecting snow and ice. Then when we have some clouds here, we have low water clouds with small particles with yellowish, because we have here the greenish 1.8 channel that gives us information about the particle size, and we get also information about the temperature. So it's really nice product also to detect snow and ice cover. And when we have high and cold clouds in this product, we can see them with violet color, so it's a little bit easier to distinguish the difference with the ice and snow between the cold and high clouds. And if we have these low water clouds with smaller particles, they are a little bit more yellowish, so they are quite easy to detect from the product also. Then we have a day microphysical, and this is not that easy to interpret, but it's really good product in many ways. But really quickly, again, to show that we can also see the snow and ice coverage really nicely, and it's really easy to define where we have clouds and ice in the sea areas also. But then we have a lot more information about the microphysics of the clouds when we have, especially here in Sweden, we have these areas where we have big water clouds with large particles that are more like salmon red than green when we have small particles. So it's really really nice product all in all. But I can see that we are running out of time already, so I have just 2 more products to show you. This one is Cloud Phase RGB, and we just noticed before the presentation that there are several similar products, and there are used 1.6 channel, and our production has been using 2.25. So I just tried to make sure that I understood correctly the channels, but they are probably going to change this channel for 1.6. So just for your information, if you have seen this product with different channels, so there are several different kind of cloud phase products. All in all, it was really nice surprise to see that this is really good for defining the line where we can see where the snow cover ends here, and also it's really easy to distinguish the ice and snow from the clouds. And in this case, the cold thin high clouds are pinkish because we have the red part from the temperature information from the 10.7 channel, and then we also have information about the particle size with the blue channel. So we have also information about low water clouds with small ice particles. So in this case, we can see them with the bluish colors. But all in all, again, for detecting snow and ice, it's really good products also for that. And then finally, maybe the most interesting product, at least in my opinion, is this Snow Age RGB. And this is really nice product for defining or having also information about the microphysics of the snow and ice cover, because we have information about the age or the how moist the snow or ice is. It doesn't mean that it's melting. If you can see some orange colors, it can mean also that the snow or ice cover is older because of the particle size of the snow or ice when it's getting older. And whenever you see these lighter orange colors, then it means that it's dry or new snow. And it's really easy also see the snow cover under thin or fractional clouds. So it's been really nice product. But it's not that that simple than the previous ones, because there is a special algorithm for defining this product. So I just wanted to show you that which channels have been used in the calculating this algorithm that is producing this RGB. So I think this is about all I have to say at the moment. I want to thank you all for your attention, and I just realized that I have been talking 40 minutes, so thank you very much for listening.